Last my kind of in-person conference is probably like 3 years ago at ApacheCon. I meet a bunch of the Apache Pulsar community members at that conference. But right now, I'm going to talk about modern event-driven application today. It's about event-driven application done right. So, but before I jump into that, I want to talk a little bit about the people in this room, talk about the Pulsar community in large. So first, I would like to say thank you to one of the sponsors here, PingCap. PingCap created this amazing tool called OSS Insight. OSS Insight is powered by TiDB, and also soon will be powered by Apache Pulsar. And what it does is it captures all the events that happen and is happening on GitHub, and provide a deep analysis over those events and offer insights to open source project. So there's a really cool features that offered by OSS Insights that it displays the data changing over time via a bar chart race. So this is a bar chart race of the total number of pull requests from 2011 till now for the top 10 open source project in the messaging and streaming space. So please bear with me to watch this video for a couple minutes. So as you can see in the beginning, you probably don't see any pull requests coming out from Pulsar or even Kafka. It's just at that time, it's most of the messaging system are kind of a previous generation messaging system. And starting from 2011, you start seeing the number of the pull requests coming out from Kafka is actually increasing over time. And then it's actually catching up really fast and arrive at the first place. But after like 2017, Pulsar is open source and more people adopting Pulsar, the number of the pull requests of Pulsar is actually accelerating very fast. So right now, it's in the second place. But after enter 2021, and even getting into 2022, you can see the speed of the growth of the number of the pull requests is actually accelerating quite a lot. So the first time I saw this diagram is I was really excited and impressed by what we have been achieved as a whole community here. It has been an incredible time to see the entire community growth. And that's what is happening in this room and in this community. So there are about more than 560 contributors making contributions to the core Pulsar repository. There are more contributors making contributions to the entire ecosystem surrounding around Pulsar. So there's about more than 7,000 Slack users in the Pulsar community. The number was doubled last year. And there's really a rich and growing collections of knowledge of comments, suggestions, problems, patterns, contributions that accumulated in the community. And the main Pulsar code base right now has more than 10,000 commits, and it's growing year over year. There's about thousands of organizations adopting Pulsar for its mission-critical applications. So this is a kind of snapshot of companies using Pulsar in production to support its mission-critical business applications. From MarTech to financial services to IoT manufacturing to retail, e-commerce to more. And Pulsar has become the fundamental messaging and streaming data infrastructure to support all these mission-critical business. For example, if you are WeChat users, if you are sending lucky money to your friends, all this money goes through Pulsar. Tencent, the company behind WeChat, actually built its entire billing platform on top of Pulsar for processing hundreds of billions of transactions every day. Didi, one of the largest ride-share companies, actually using Pulsar for deliver its real-time experience for their passengers and drivers. Companies like Intuit, Verizon, Splunk, Yahoo, Yahoo Japan, Flipkart are adopting Pulsar as its fundamental company-wide message bus to supporting all its messaging streaming needs. So I think we are witnessing across of these, across the community growth, the increase of the number of use cases on Pulsar, the rise of a new major platform around messaging and streaming. And I think this has a big opportunity to grow as big as the entire database world because the enterprises is moving towards real-time and streaming. But wait a minute, what do you exactly say about messaging and streaming? So there are so many different kind of applications across every industry. And it's really hard to reason about all these different new messaging and streaming applications, where they are from, what they are used for, and what is the real difference between messaging and streaming, and where is the boundary. So the answer to that is there's no really boundary between messaging and streaming. So messaging and streaming are just techie words. Instead of talking about messaging and streaming, we should probably step back to looking into the use cases. We can kind of cut the entire world into two large buckets. One is the business application running in the application domain. Those are end-user facing, business service-oriented applications acting on real-time business events, on taking actions. On the other hand, those are data pipelines running in the data domain, which kind of getting the data from place to place. So really, there's no distinction between these two. If a data pipeline gets complicated, it involves more business logic, it probably becomes an application. So it's not really matter about like messaging and streaming. We have to go back looking into the use cases. So, but today I'm going to talk mostly about my right-hand side, which is the applications. What's happening to the business application world? What is the right tools? What is the right API we should choose to get a business application done? So at the beginning, I think things are really simple and easy. So probably everyone have been writing a web service before and using HTTP and RESTful API. So HTTP and RESTful API are kind of the standard and widely adopted protocol on implementing business applications. Almost every program language provides a rich tool set on writing web services efficiently. This works really well if your business is really small, but gets harder as they grow, more complicated, more services being introduced, the more services are interconnected with each other. So we quickly getting into a situation that dependency of those services became really complicated, and it's impossible to capture because these services also constantly evolve over time. For enterprises that was not born in cloud and deploys decades of worth of legacy software, there's a danger of using microservices, which increasing the management complexity instead of improving organizational efficiency. So such a system that can quickly get into the scalability limits when they are using synchronous communication. Because service A might be waiting for service B to complete a request from service C. Resources are blocking and waiting on every node on completing its chain request. And it increases the pressure on the system as a whole. So when there's a service fail, or even it's just slowed down, it can quickly and negatively impact the entire user experience of your business. And eventually, your system of the services would end up feeling the same pain across all the services. So how to solve the problem? And we have to kind of step back and looking into like company scale. Majority of your process, majority of your application that comprise your business are actually asynchronous to one another. So over the past few years, we actually see a revolution that is organization needs to be real time. And in order to be real time, those services need to be decoupled. And those services need to become event-driven, and that's the revolution coming in as an event-driven architecture. So at the heart of an event-driven architecture is all about events, about what is the right platform you should choose to power those events. There's already a whole ecosystem of tools that has been existing around for decades that is looking into solving this problem. And I think Pulsar is actually coming in to disrupt this space with a different thinking. Is what we have been thinking about, what is the right data abstraction that we should provide for an event-driven architecture? What is the right API that we need to offer to the developer? Is it just stream? We also need to offer queues, or we need to offer tables? And what are the primitives that we need to offer to simplify the entire process so people can use the tool, the platform to build scalable, reliable, distributed, event-driven applications? And what are the processing semantics we should offer to meet the business requirement? And putting all these fundamentals together, what is the tool set that we can give developer to get a job done? And so in order to answer all these questions, I would like to welcome Matteo Merli, co-creator and PMC chair of Apache Pulsar, CTO of Stream Native, to the stage to talk about what are the fundamentals that we offer to the event-driven applications for the developer building event-driven applications. Welcome, Matteo.
Hi, everyone. Thank you. Thank you, CG, for the nice introduction. So before I start going through all these abstractions, API, and so on, I want to take a small step back and see how the applications have evolved, right? So CG was mentioning that we had the monolithic applications, and it makes sense to break them down. It makes sense to break them down for multiple reasons. One is organization. Like one of the issues with the monolithic application is not just the technical issue, is also the people issue. You want to have different teams doing different things in isolation. And it's all good. And at the end, bear with me with this example. There are a bunch of boxes and a bunch of lines between them. It's not important to understand what is doing what. But the point here is that we broke down this monolithic into application into multiple things, multiple services. Each of them is doing only a part of that, of the whole thing. We need to orchestrate these microservices. We need to make sure that there is integration between them. And typically, the integration comes with topics. And topics act as buffers and act as integration point. The important part here is that we've been adding all these components and tying that together. And if you look at this picture, the first thing that you can see here is that it becomes easier to scale this application. It is not monolithic. It is not like a single thing. You can scale the front end independently from the backend services or from the analytics services. All these are completely separated. And they all talk using topics, but they use different semantics. They don't all use the same things. For example, like you get a front-end service that takes HTTP request, and there's a new order to sell something, and it may be putting that request into a topic. Now, you may have this backend service that takes these and does some business logic. And maybe it has to keep some state around these orders. So it has to keep track of, there's a new order, what's the state, is new, is a fulfillment, and so on. And it can be done with a topic, for example. You may even need to use transactions here. And all of these are using slightly different abstractions, slightly different APIs. And finally, on the right side, you can see the analytics. So analytics is a more of a streaming use case. But as you see, there's not like an application is not going to just use one single feature, one single abstraction. When your application is complex enough, you will be using conjunctions of them. So you'll be using a queuing model. You'll be using a table view of the data. You'll be using a streaming abstraction. So it is going to be an all-encompassing set of API abstraction that lets you build a very complex application, very powerful, that is very scalable, and as well it is very observable, because since all your interactions are happening in topics, it is very easy to plug in and observe what is happening on each side of your system. So as CG was mentioning, we thought a lot about these problems and how to have the best primitives to solve all of them. And it comes up with what is the right data abstractions, what is the right set of APIs and primitives, and the processing semantics that you can offer to application developers and architects to design even more and more complex applications, and the right tooling. And you can translate this into topic as the unit of data abstraction. And with the topics, you can see topics in multiple ways: streaming, queuing, tables, and shared access versus exclusive access, different processing semantics, and different levels of abstraction for different needs in the application. Starting with the topics, topics typically can be seen in two major ways, right? One is the traditional PubSub definition of topic. Essentially, you have a asynchronous broadcast of messages to a set of consumers. Main purpose is the couple of producer consumers, and one of the main ideas around PubSub is that you have subscriptions that have durable state. So subscription is managed by the system. So you don't decide where to read, the system will tell you where you're reading from. On the other side, you have replayable streams, which is more about infinite retention of data or very long retention. And this is the source of truth of everything that has happened into your system and can be read from any position. So you can read from here, just go back, and so on. The events also can be stored in a raw format, like event by event, or in a columnar format, which is more like also used to have different ways of seeing your data, streaming way or more batch access. But it is the same data. And if we dig down, there are multiple ways of using this topic, right? So the abstraction of the streams, unbound sequence of SAN, which is ordered, replayable, and partitioned. And the queue. When you see your topic as a queue, it's kind of like different ways of seeing the same thing. But a queue is a fundamental decoupling mechanism. A queue is a buffer, right? You can publish events, and this will hold them until they're processed. And the queue also is a scheduler. A queue is used to distribute work across multiple workers. And with multiple strategies, like either round robin or per key ordering if you want to retain ordering. And you have these individual tracking of messages and perhaps delayed delivery, and to have more complex logics around the routing. And the third one, which we have introduced recently, is a table, right? So how does the table fit in here? So if you see a topic, you can translate your topic in a projection and see that as a table view. Essentially, it's a map where the key is the message key and the value is the object of the event. There are multiple usages for this, right? So for example, like you can use the table as a way to share state across multiple processes. In the diagram before, we had a backend service, but you may have like 10 instances of this, and you want to share some state between them. So the table is an abstraction that lets you have this sharing across different processes in multiple ways. Another common usages for this is a distributed cache. So yes, you could use a separate service, but this basically will place always up-to-date cache into every single of the processes. So the reads are always going to be local and going to be very efficient. And finally, the table is integrated with transactions. So if you read from a topic and update your table, then it can be an atomic transaction operation. So it will be very consistent, the result. And the next part is about shared versus exclusive. There are like different ways here. So you can have shared producers or shared consumers and mix everything in between. So you can share or share an exclusive subscriber, or you can have exclusive. There are different ways to see that the exclusive access for producers and exclusive access for consumers. So for producer, it typically means that you want to have a single linearizable history for each producer. So you can have different epochs that are not interleaved with different producers. And that is typically kind of like a power user kind of feature if you're implementing some kind of like storage system, for example. But that's very powerful. And it allows you to implement things like leader action, because you can be the leader and communicate all your decisions as form of messages that are published on that topic, because you are the only one writing there until you crash and someone else will take over. For consumers, it is this access level is a bit different, as in you can have shared consumers which is more about distributing work, right? Like this work distribution, or you can have exclusive subscribers when you say, I want to receive all the data in the right order and not share with anyone else. And the fourth point is the semantics of the processing. So this is like the traditional, at least once, which Pulsar provides by default. When you receive and acknowledge, you have data can be received more than once. I think everyone is familiar with this, right? So you don't lose data, but you can have duplicates. The list of the guarantees it is at most once when data can be dropped, and we have this with no persistent topic, for example, and the other one is exactly once, where you have the messages can be received more than once, but the effect of their processing will be stored only once. So it's not that the message is only received once, it is the processing, it is only going to be effective once, with no missing data. So the way we achieve this is through the process transactions, which were introduced in PIP 30, and started with a preview in Pulsar 2.8, but in 2.10 is really production ready. So I encourage more and more people to try transactions and to start using that, because that's a very powerful feature in Pulsar now. The last part is around what is the right level of abstraction, what is the right client library, what is the right APIs, and so on. So there are multiple ways of seeing the problems, and there's not one single answer here. At the bottom, basically, we have the client libraries. Client libraries are very efficient. They're using a custom protocol based on TCP. There are all the tricks to make it as efficient as possible, and you have all the power. So you can decide to use every single feature in Pulsar. You can tune it every single piece. And we have support for client libraries in many languages, from Java to Go and C++. No, so yeah, it's a growing. The support is growing, and also the quality of all this client library it is growing as well in non-Java languages. There is also a REST API in Pulsar, and mainly it's for admin requests, right? So people are familiar with Pulsar admin, Pulsar CTL. You can control everything in Pulsar. Since PIP 64, there is also a lot of work into introducing a REST endpoint for data publishing. So this does not substitute client libraries, but it can be useful for many cases in which, say, if you're using, say, Haskell, and you want to publish on Pulsar, there is not an available client library, you can use REST. And that would be, you may not have all the features, but it would be very easy to use. You don't need to use any client library, and it gets you up to speed very quickly. The other API set that we have introduced a long time ago in Pulsar is a functions, Pulsar functions. So for those of you that are not familiar with Pulsar function is kind of like a serverless event processing model. So we call it like lightweight processing. We are not like, it is not Flink. We're not doing like complex pipelines, but it is a single pass compute framework. And read some topics, apply some logics, which can involve calling different services, and then output to a set of topics. So function, you can see that as an easier way to write your logic. At the core, function is based on using Pulsar client, processor and consumer, but it abstracts that out of you. So it takes care of how to run it, deployment model, and so on. So it makes it much easier for people to write event-driven application, because they don't have to think about producers and consumers. They just think about, I get an object, I do some transformation, I return that object. So you have this kind of like a code that you can choose from, right? So you can be more complex, but have more flexibility, tune it the way you want it, or easier to use, easier to use, but less flexible. And the question is, what can we do more to get it more and more easier for people to use? Because functions, yes, it is easier than writing your application, but At the same time, you still have to write code. You have to write code, you have to compile it, package it, and submit it to the cluster. So the idea here is that why can we let people just submit a SQL query and do a subset of what you'll be able to do with Pulsar functions? For example, we've been thinking a lot about this, and we have been introducing this PF SQL, which essentially it is a way to make Pulsar function more accessible to developers and even to non-developers. And this is basically a framework that is designed for Pulsar function, especially, and with in mind all the use cases around filtering, transformation, routing, which are kind of like the most common use cases that people are using functions and these similar technologies. And the other one idea here is to also use this for transformation that happens within the context of Pulsar IO connectors. Either when you receive from a source, do some pre-processing before publishing on a topic, or in a sync before handing that message or that object at the point over to a sync connector. There are these few examples here how to do filtering, which feels very, very easy and natural, like insert into output topic, select star from input topic, and then apply some where clause with a filter between either on the keys or the field of message, and using the embedded schema of the topic. Same with transformation. You can do projections, you can do apply functions on the fields and so on, or routing. You can decide basically based on the key or based on some property of the message, route to a set of topics. So essentially, you can do all these tasks without writing real code. SQL is still code, but it is easier code. Just want to clarify here. So this is not like a complete ETL or any complex things, but it really lowers the bar for people to integrate different services and control the way that the data is transformed and filtered or routed to right components. So I recommend you to listen to the talk by Nang around simplifying Pulsar function development with SQL, which is like 3:20 this afternoon, and he will go through all the reasoning behind the SQL here and the implementation as well. And just to recap here around all these primitives around topic, streams, queue, and table, and as a concluding remark here, I just want to kind of recap here that when you're building this complex event-driven application, you will necessarily going to need a wide set of range of abstractions, API and semantics. So not just one single use case that is using a queue or one use case that is using a streaming model and so on. So it is by necessity going to be more complex, more nuanced. And we really think that Pulsar is a system that solves all these problems in the most natural and comprehensive way. With very good support for all the queuing and streaming, table, transactions, and it is a comprehensive set of APIs and abstraction that really you can use as a framework to build complex and event-driven application. So with that, I'll leave you to the next one, and I really thank you for being here to the first Pulsar Summit in person. Thank you.